This is a Poisson problem. Let's read it and then we'll review the Poisson distribution characteristics. It says plastic panels are made and the average number of defects per panel is 0.8. If the data is a Poisson distribution, we need to answer these two questions. What is the probability of exactly 4 defects in a plastic panel? And what is the probability of finding 1 or fewer defects in a panel? So let's go ahead and review. Let's review the characteristics. Okay, so the Poisson distribution is experiments. A Poisson experiment consists of counting the number of occurrences of an event over a period of time, area, distance, or any other measurement. It could be distance, space, anything like that. The mean of the Poisson distribution has to be the same for each interval of measurement. So for example, if it's 0.8 per panel, then it would be the same for another panel. So over 2 panels, it would be 2 times 0.8. The number of occurrences during one interval is independent of the number of occurrences in any other interval. And because the experiment counts the number of occurrences, there's really no cap. So we could have as many defects as there could be. Remember, with binomial, we had a cap on the values that the random variable takes on because we have a set number of trials. But in here, we don't have a set number of trials. The experiment could result in any number of values for the decision variable. So to solve this problem, we'll start with assigning values of 0, 1, 2, 3, and I'll just take it to as many. We won't end up needing all of these, but I'm taking it up to 262. So now to compute the probability, we say Poisson dist, and there are 3 parameters that we must know. One is the x value, so that would be our, it's M6 actually, for 0, the position of 0. And then the next is the mean. In this case, the mean is 0.8. Actually, let me fix the mean to be over here, so in case we want to change it. So that's that. Oops. I want to, it's here, and I want to fix the cell reference, and somehow it didn't fix the cell reference. Okay, I'm gonna try again. Okay, now it did. And then I do not want cumulative. I want the probability of exact value, so I'm going to put 0, or you can put false. And now where was that? N2. So here I want to put 0.8, which is my mean per panel. I'll put it over here, mean per panel. Okay, so now I can copy these down, and you can see that past 6 or so, they all become 0. These are all in scientific notation. All right, so now we're ready to answer our questions. What is the probability of exactly 4? Exactly 4 is over here, and I'm going to put that over here, so that equals to 0.0077 almost, which is rounded here. Okay, now keep in mind that it says what is the probability of finding exactly 4 defects in a plastic panel, so that's only for one panel. And then the next one says what is the probability of finding 1 or fewer. So 1 or fewer means 1 or 0. So that would be the sum of 0 and 1 probabilities. Another way that we can compute this is to use the Poisson. And we still say 1 as our x value. The mean is still 0.8. And but now I want to say true for cumulative, because I want the probability of 0 and 1. Everything lower than 1 or equal to 1. So you can see that these two numbers now match. Now, what if the probability that we're looking for is for not only for one panel but for 3 panels? So probability computed for 3 panels. Now we need to fix the mean for the 3 panels. The mean for 3 panels is going to be equal to 3 times 0.8, because it's 0.8 per panel, so 3 would be 3 times as many. So now we can compute these equals Poisson dist for x being 4, exactly 4, mean being 2.4, and I want to say false or 0. So now the probability of having exactly 4 defects in 3 panels is almost 0.125 or 12.5%, versus it was almost 7 thousandths when we were working with only 1 panel. We can also compute Poisson dist for 1. Mean is 2.4, and I can say true now, or I can put 1 for cumulative, and now you can see that the probability of having 1 or fewer defects in 3 panels is almost 31%. Okay, I hope you found this helpful.